Okay, guys, this is lesson 4A, common bases. And for this lesson, you're going to want this little yellow sheet that I handed out for this unit, okay, because it gives you the powers. And that's what we're going to do today is we're going to create common bases. So you need to recognize these values and what base they go with, okay? So like I said, this is lesson 4A, and we're going to focus on pages 28 and 29 for this lesson. So this is lesson 4A. And we will do another day of this, which will be 4B, which will be the next two pages, which is 30 and 31. But basically, we're going to use the properties of exponents. It says to simplify each side of the equation if possible. The whole goal is to get the same base. That's why we call it the method of common bases. Because if the bases are the same, then the exponents have to be equal to each other. Okay, and you'll see what I mean here in a minute. All right, so I'm going to do 10 problems with you. That's the goal. And then you're going to do the remaining 10 on your own for homework. All right. So type 1, it says type 1, they already have the same base. And so if 5 to this power is equal to 5 to this power, then obviously the exponents have to be equal to each other. So it's simply just setting the exponents equal to each other once we have that common base. All right. And then this is just solving a two-step equation. We want to get the ends on both sides. So we just subtract. I'm going to subtract one end from both sides first, and then I'm going to subtract the 5. I'll just write it like this. So I get 3n equals negative 12, and then n would equal negative 4. Okay, so we can have all types of values for answers. We can have negatives, positive, fractional answers, but I'm just going to do a quick check because it is real quick. So basically 5 to the 4 times n plus 5 has to equal 5 to the n minus 7. If I substitute a negative 4 in for that, I'm going to get 5 to the negative 4 plus 5 equals 5 to the negative 4 minus 7. This will give me 5 to the negative 11th power. Over here, this is negative 16 plus 5, which is 5 to the negative 11 power. And obviously, they're equal, so that checks. Okay? All right, the next one I'm going to do is number 4. So this one's a little bit different because these are multiplication signs right here. It's kind of hard to see, but these little dots are multiplication signs. So I'm going to use step 1 here where I have to simplify using the properties of exponents. So since these have the same base and I'm multiplying, the base stays the same. And when I multiply, I add exponents. So negative 4 plus 9 is a positive 5. All right. Same thing on the other side. The bases are the same. I'm multiplying, so I'm going to add these together. Okay, so I'm adding this 1v plus 4 to 2v plus 11. 1v plus 2v, if I combine the v terms, I get 3v. And plus 4, negative 11, gives me a negative 7. Okay, so now that I have common bases, that means that the exponent 5 must be equal to 3v minus 7. And I can just go ahead and solve. So I'm going to add 7 to both sides. And I get 12 equals 3v, divide by 3, and v is going to equal 4 for this one. Okay, and again, the check isn't too time-consuming for a check. If I were to substitute 4, well, obviously this side is not going to change regardless of the variable. So this side still simplifies to 10 to the 5th power. And on the other side, I'm going to have 4 plus 4 is 8, so this would be 10 to the 8th. Times 10 to the 2 times 4, and I substitute the 4 in for this, I get 2 times 4 is 8, and 8 minus 11 is negative 3, and my rules of exponents, when I multiply, I add exponents, so I get 10 to the 5th equals 10 to the 5th, which is a check. All right, on to the next one. I'm going to switch over to the odds now because the odds are harder, and I'd like to give you the easier ones for homework, obviously. So now we're going to start without a common base, and we have to get the common base. So hopefully you recognize that 36 is the same as 6 squared. So basically I'm going to rewrite that as 6 squared since the left side of the equation has a base of 6. Okay, so basically you have to find the common base, create the common base, and now I can solve this like I have the above answers or equations that already had the common base. So this is going to be 2x minus 10 equals 2 because I'm just setting my exponents equal to each other since the bases are the same. I'm going to add 10 to both sides to get 2x equals 12. I'm going to divide by 2 to get x equals 6. So x equals 6 is the solution. And again, if I check my answer, 2 times 6 minus 10. So this is 12 minus 10. This is 6 squared equals 36. And that's a check. All right, number 7. Well, if we have a fraction involved here, we can write this as a 7 with a negative exponent. So 1/7, okay, these are not in the yellow sheet, but this is the same as, we can think of this as 1 to the 7 to the positive 1 power. So if we want to write it without a fraction, it's the same as 7 to the negative 1 power. Okay, so 1/7 is the same as 7 to the negative 1. Over here, we're going to keep the base of 7 because that's our common base. And then I can just simply set my exponents equal to each other and solve this two-step equation. So I'm going to subtract 11, 4x equals negative 12, and then divide by 4 to get x equals negative 3. Okay, I'm going to do a quick mental check. If I plug a negative 3 in for this, I get negative 12 plus 11, which is 7 to the negative 1 power, which equals 1/7. That's a check. All right, next one. Common base. Well, if you don't know what 27 is a power of, because it looks like our common base would have to be 3, you can look at your sheet and look and see that 3 to the 3rd power is equal to 27. So I'm replacing 27 with 3 to the 3rd power, and it's still raised to the 2x plus 6 power. Okay, these are probably the trickiest problems. And now we use our exponent rules. If we have a power to a power, we multiply. And we have to remember to distribute. If we're multiplying 3 times 2x plus 6, we have to distribute that 3. All right, so this is the same as 3 to the 6x plus 18 power. When I distribute that 3, I have to multiply that exponent of 3 times the 2x plus 6. And over here, I'm going to get 3 to the 2x. And as soon as I have those common bases, I can set the exponents equal to each other. So I end up with 6x plus 18 equals 2x. And then I'm going to solve. Just because I don't like having an equation equal to 0 if it's linear, I'm going to subtract the 6x. Even though I'm working with negative values, it's not a big deal. When I divide by negative 4, I'm going to get x equals, I'm just going to reduce this. 18/4 reduces to 9/2, so it's going to be a negative 9/2. If you want, you can rewrite it as a decimal. Negative 4.5 equals x. All right. So either answer is acceptable. This looks like a weird answer. Maybe it's wrong. I don't know. Let's check it. Okay, so I'm just going to substitute back into the original. So 27 times 2 to the negative 9/2. I'm going to leave it as a fraction, plus 6 has to equal 3 times 2 to the negative 9/2. All right, well, if I'm multiplying 2 times 9/2, the 2's are going to cancel out, and this is going to be 3 to the negative 9 power. Okay, over here, same thing. I'm going to get, the 2's will cancel out. One's multiplying, one's divided. And negative 9 plus 6 is negative 3. So this is 27 to the negative 3rd power. And I can kind of use my common base thing again. So 27 is 3 to the 3rd to the negative 3rd. And if I multiply these together, it would give me 3 to the negative 9th, which is the same as this side. You can also just bring this up in Desmos, right, and evaluate this side. It'll give you the actual value of 27 to the negative 3rd, which is going to be the same fraction as 1 over 27 to the positive 3rd, so it'd be a pretty small number. And if you put the other side of the equation in as well, it's going to give you the same exact decimal. Okay, so these are pretty fairly easy to check. All right, we're moving on to the next page, and I'm going to pretty much stick with the evens. I might do number 19 with you at the end. But basically, we need to find the common base here. Common base. I'm going to just write CB here to write the common base. Now, some people may be thinking 8, but 8 to the 1st power is 8, and 8 squared is 64. So that's no good. We can't use a common base of 8. Maybe you're thinking 16 is the same as 4 squared, but 4 to a certain power, we're not going to get 8. Okay, 4 squared is 16. There's no 8 involved, so we can't use a base of 4. For this one, the common base is actually going to be 2. Okay, so we have to change both exponents. So for 16, I'm going to say 2 to the 4th power, which is 16. Again, you can use your yellow sheet if you're not familiar with that. And that's raised to the 3x power. Okay, so instead of 16, I'm going to call this 2 to the 4th, raise it to the 3x power. 2 to the 3rd power is 8. And after doing a few of these, you'll probably memorize a lot of these. Okay, now that we have the common base, we're going to take the power to a power and multiply these exponents. So 4 times 3x is 12x. And over here, we have to remember to distribute because we're multiplying these two values. So we get 3x plus 6. And then we can simply solve. So I'm going to get the x's together. I get 9x equals 6. I'm going to divide by 9. And I get x equals 2/3. All right. Again, it's not too much trouble to check. So 16, 3 times 2/3. That's going to be just the same as 16 squared. Equals 8. 2/3 plus 2 is just 2 2/3. Okay, and I can rewrite this as 8/3. So it's 8 to the 8/3 power. And look, it's probably easier to put these in the calculator to check them. So 16 would be 2 to the 4th squared. This would be 2 to the 8th. And over here, we can do the cubed root, right? Because we can use the power, change it from flower power to a radical. So this would be the same as 2 to the 8th power. So 2 to the 8th equals 2 to the 8th, and that checks, which I'm sure you wouldn't take the time to do that. So if you're going to check it, you can just substitute that into Desmos, get the decimal equivalent, or in this case, it's going to be a pretty large number. Actually, 2 to the 8th would be what? 2 to the 5th is 32. 2 to the 6th would be 64. 128 would be 256. So this would come out to be 256 equals 256 if you check it. All right, moving right along. All right, we have 81 1/3. Well, if you have a fraction with a denominator of 3, the only real choice is to do 3 to the -1 power. Okay, it's that simple. So that gives us a clue that our common base for 81 has to be 3. And if you look at your yellow paper, you can look at the exponents for 3, and we see that 3 to the 4th power is 81. So instead of 81, we're going to represent it as 3 to the 4th, and then it's raised to the 2x plus 5 power. All right, now that we have the same base, we can multiply exponents, and here we'll get 8x plus 20 when we distribute, right? 8x plus 20 equals -2x. Okay, this one I'm just going to do a little bit differently. We can add 2x to both sides because I know some of you will. We just will have a 0 as a placeholder. So this will be 10x plus 20. Then we could subtract 20, or you could divide out the 10. There's different ways to solve an equation. Again, the beauty of math, we can think differently. As long as we're following the rules of math, we can get the same answer. And x equals -2. Okay. You guys know how to check this. So I'm not going to check it. I'm just going to look on my answer key. I've already done this, and I did check them all in my answer keys, so just to save some time on the video. All right, so for here, we have to find the common base. Hopefully you recognize that 27 is 3 to the 3rd. So we're going to try a common base of 3. And if you look on your sheet, you should see that 3, okay, we're looking at our sheet. Ooh, there it is. And we see that 3 to the 5th power, there it is 243. So our common base for this one is 3. And we have 3 to the 3rd to the 2x equals 3 to the 5th to the x minus 2 power. Okay, again, we multiply the exponents because that's the power to the power rule. We distribute here. We get 5x minus 10. We subtract the 5x from both sides. We get x equals -10. And donezo. I've already checked it. All right, here we go. 2 more to do. All right, so this one, hopefully you recognize 81. That's a power of 9. So 1 over 81 is the same as 1 over 9 squared. Okay, we don't want to write it as a fraction though, so we're going to write this side of the equation as 9 to the, hopefully you said -2nd power. okay, because 9 to the negative second is the same as 1 over 9 to the positive second, which is the same as 1 over 81. Over here, we are going to use our properties of exponents, and we know if we have the same base, we can add the exponents. All right, so we're going to add 2x plus 2x is 4x, and then we have that plus 4 to attach on there. All right, so now we have the common bases. We can write our equation. 4x plus 4 equals negative 2. Subtract 4 from both sides. We get 4x equals negative 6. Divide by 4, and we get x equals, if we reduce 6/4, we get 3/2, so negative 3/2. Or, if you really like the decimal equivalent, negative 1.5. All right, let me check my answer key. Number 18, I get negative 3/2. I checked it already. Check, we're good. Moving along. Last one, I said I'm going to switch it up and do the number 19 with you for this one, just because I think it's, well, they're probably similar, I guess, in for difficulty level, but all right. So 1/7, I have 1/7, 49, and 7. So hopefully the common basis is kind of jumping out at you as 7. All right. 1/7 is the same thing as 7 to the negative 1 power. 49 is 7 squared, and that's raised to the x minus 5 power. And then we have times 7 to the x minus 9. All right. So before I try to add these exponents, I have to have a common base. Okay. And I'm still not ready to add because I need to simplify this. So I'm going to change this to the 7 to the 2x minus 10 power times 7 to the x minus 9, or 1x minus 9 power, same thing. And over here it's still 7 to the negative 1. Okay, now that I have common bases and I'm multiplying, I can add these exponents to change it to, this would give me 3x, and a negative 10 and a negative 9 give me negative 19. And over here I have 7 to the negative 1. All right, now that I have the common bases, I can say negative 1 equals 3x minus 19. Okay, some people would rather write it 3x minus 19 equals negative 1. Oops, I forgot the 19 there, the 1 of the 19. So I'm going to add 19. And I'm going to get 3x equals 18. Divide by 3. And x equals 6. All right, I got that on my answer key. I already checked it. And we are done. So your job is to do the remaining 10 questions on these 2 pages. Have fun. And if you have any questions, get a hold of me. Email, send me a message on Canvas. All right. Have a nice day. Take me a second to close out of here. Waiting patiently.